Hello students, welcome to online lecture series of discrete mathematics. Now last session we have studied different types of graph. It is directed graph, undirected graph, right? Null graph. Now today we'll see the homeomorphic graphs. So what is this homeomorphic graphs? The two graphs G and G star are said to be homeomorphic if they can be obtained from a same graph. What? They can be obtained from a same graph. This graph is the same. Using same graph or isomorphic graph by this method. The graph A and B are not isomorphic, but they are homeomorphic since they can be obtained from the graph C by adding appropriate vertices. So here the homeomorphic graph means what? This can be obtained from the same graph, right? Or the isomorphic graph, right? So you know the isomorphic graph, that is a number of vertices, number of edges, right? Are the same. Let's say here, what is isomorphic? Last session, the isomorphic graph. The consider a graph G, V, comma E, and G star, comma E star are said to be isomorphic if there exists a one-to-one correspondence between their vertices and their edges, right? So here this is not isomorphic. There is number of vertices are same, number of edges are same. That is a degree, right? Degrees are same, right? Then adjacency is preserved, right? Then we can say that the given graphs are isomorphic graph. So here in homeomorphic, right? See here, this a graph C, right? Using this is your common graph. Using this graph C, right? Here graph A and B are not isomorphic. These two graphs are not isomorphic, right? But they are homeomorphic because they can be obtained from the graph C. So this is your graph C containing 5 vertices. Here by adding some appropriate vertices, right? So this here appropriate vertices. So you obtain a graph again by adding some appropriate vertices, right? So obtain a graph. So this is a homeomorphic graph. Next, subgraph. So what is this subgraph? A subgraph of a graph G is equal to, right, set of vertices V and set of edges is a graph. It is G dash is equal to in bracket V dash comma E dash, in which V dash is a subset of V and E dash is a subset of V. Means this V dash is the set of vertices of G dash is a subset of V, and this E dash is a subset of V, and each edge of the G dash have a same n vertices in G dash as in a graph G. As in a graph G. So this is your a graph, right? So in a subgraph, you have to note one point: a single vertex is a subgraph of a given graph. So this is your graph, right? So this is your graph. Right? So for this graph, number of subgraphs can be obtained. So this A, B, C. So this is one subgraph. That is, this A, B, C are these 3 vertices are the subset of vertices of this graph, right? Say number of edges also subset. Means as per the definition of subgraph, this V dash is a subset of V and E dash is a subset of V. So what is this V dash? V dash containing these 3 vertices A, B, C. And what is this V? V are the number of vertices for this graph. That is A, B, C, D, E, F. The 6 vertices for this V. Same this one, right? This is also a subset of this graph. So we can, this is a subgraph of this graph G. Same, this one is also a subgraph of this graph G. And this next diagram is also a subgraph of this graph G. That is, number of vertices in subgraph is a subset of your a graph, right? Same number of edges in a subgraph, that is E dash, is a subset of your E, that is number of edges in a graph. So next is a complete spanning subgraph. Next one is a spanning subgraph. So what is a spanning subgraph? A graph G1 is called as a spanning subgraph of G if G1 contains all the vertices of G. G1 contains all the vertices of G, right? Means whatever a graph is given, using that graph, whenever you draw any spanning subgraph, this spanning subgraph must contain all the vertices of that graph. All the vertices of that graph. So in a previous subgraph, as you see, for this subgraph, here this subgraph doesn't contain all the vertices of this graph, right? This only some vertices of this graph are present for this subgraph, right? But in spanning subgraph, what in spanning subgraph, all the vertices are present, right? So A, B, C, D, E, F, all the vertices are present for the spanning subgraph. So this is spanning subgraph or the previous graph. Next, complete graph. So what is this complete graph? A graph G is said to be a complete graph if every vertex in G is connected to every other vertex in G. The complete graph G must be connected, and the complete graph with n vertices. Complete graph with n vertices is denoted by this Kn, k to the base n. The figure shows the graph K1 through K6. So what is this n? What is this n here? N is the number of vertices. N is a number of vertices of the given graph. So here, as per the definition of complete graph, whatever vertices present in a graph G, right? These vertices are connected to each other. This every vertex is connected to every other vertex. Then and then only we can say that a given graph is a complete graph. A given graph is a complete graph. So, whatever different examples, right? We'll see in next session.